You guys can see this okay, right?
Yeah.
Okay. All right. So, of course, Jeff being a complete asshole. I'll start with a beautiful one like that. So one of the first things that should start coming back, and again, it could be a little while, it could, doesn't take long for things to kind of leak out. So whenever you see a root, you should change it into fractional power, right?
Yep.
So fifth root is also a, what power? 1/5. I love it because it cuts things in fifths. So real quick side note, I wish we had never invented freaking radical notation. There's no reason for it. The fractional powers do the job. But, oh well, too bad for us. So the first thing we do is, oh, that's silly. Let's write it better. So it's going to be, oh boy, here's the first time I'm writing. Oh my God. All right, it's not terrible for me. So it's stuff to the 1/5. So chain rule is probably the first thing you hit that you're like, what the shit? So the whole idea is, the main thing happening is it's a 1/5 power. And then there's stuff on the inside, right? So it's basically something to the 1/5 power. So chain rule says, focus on the outside function first. Now it's really obvious what the inside function is, right? That's inside. So the outside is something to the 1/5. How do you take the derivative of something to the 1/5?
Move it to the front.
1/5 comes down.
Minus 1.
And then stuff, so 1/5 comes down in front of stuff. Let me put P prime here. Good George, Jeff. So it's in front of stuff. Now the power is,
Negative 4/5.
in case you never knew this, if you ever take derivatives with fractional powers, 1 minus 5 is -4 over the 5. Kind of nice. And then you multiply, of course. Why am I multiply by something?
Derivative of the inside.
Derivative of the inside, because that's good old
Chain rule.
chain rule. I love it. So derivative of this.
6e to
Good. So it'll be itself at times the 2 for chain rule. So 6e to the 2x. And then what's the derivative of cotangent? Good Lord, Jeff, you don't have enough room. Do I have enough room? I might. Minus, yeah. So minus, be careful. What's the derivative of tangent?
You gotta flip it to positive.
Good, because you're a tangent secant squared. So you're at a cotangent, negative cosecant squared. It's a beautiful analogy. Co stuff is always negative. And it's always analogous to the non-co stuff. Does that make sense, maybe? What's the derivative of secant? What's the derivative of secant x?
secant x tangent x.
Secant tangent. I love it. So what's the derivative of cosecant x?
Negative
cosecant x,
cotangent.
cotangent secant x, right? You guys see that? The analogy? Some of you guys are looking at me like, start making sense, man. Okay, I don't know how it was explained to you in 180, but to me, that's the quickest way to remember, because once you know the non-co shit, you know the co shit automatically. It's just the same stuff with the negative and all the co stuff, right? So, maybe I can squeeze this in. Minus cosecant squared plus, right? Because it's negative, negative. Okay, and that's it. There isn't really any simplification to do that would do anything good for us. You guys with me?
Yep.
Technically, you can put this on the bottom, you can put this out front, who cares? It doesn't really do anything for you, right? Okay. Is that one okay? You guys doing all right? I mean, good luck to read my writing, but if you wanted to be able to read your instructor's writing, you've chosen poorly. All right, what about B? B, so a lot of you guys, I try to console you. This B is a good example of a derivative rule you just don't use very often. You all know what the derivative of e to the x is. Thank you, e to the x, right? But we forget what the derivative of 3 to the x is. It should be basically the same rule, except there's an adjustment. Because the slope of 3 to the x is not equal to itself. It's off by a little bit. It's off by exactly a factor of natural log of 3. E to the x is its own slope. It's off by natural log of e, which is 1. So it's its own slope. Okay, maybe? So this would be, oh shit. So the derivative of a to something is itself, just like e, itself times natural log of the base times, of course, what has to show up?
2W.
2W for the chain rule. So let me write that a little bit better. 3W squared times natural log of 3 times 2W. Now, please, dear God, okay. Did anyone put 6 something? Maybe don't fess up to that, because you don't. You can't. You cannot combine these, of course, because that's 2W squared power, and this is not. Yes? So be really careful about that kind of shit. 2 times 3 to the x is not 6 to the x. Right? Those kind of things. Okay. How we doing? You guys okay out there? Sort of? Part C, you can either use what rule?
Quotient.
I don't want to do that, and I don't have to do that, because I could just do what instead? Factor the damn top and simplify. So if you took me for 180, or if you ever take me in front of the class for calculus, I always say if you can simplify it first, do it, right? Especially for derivatives. You want to simplify the damn thing. How do you factor the top? X minus 2, x minus 1, and the bottom is x minus 1. Those cancel. So I have f of x is x minus 2. What's the derivative of that?
1.
1. Kick ass.
There's actually 1, 2.
Now, if you do quotient rule, it will eventually get there. I don't know, did anybody do quotient rule and get to 1?
Well, I just stopped at x plus 2 over x minus 1 because near the end you're able to factor again, cancel out one of the x minus 1s at the bottom, and you square it from the quotient.
All right, let's try it. Let's do it, because it should.
I just didn't continue to.
Because it's a good thing to remember quotient rule. How does quotient rule work? You got a little silly song.
Yeah.
Sorry, you got a song. It's not silly, it is. I remember, here's my song. My song is top first. That's my song. So the top is first. Everything else just comes from that. Listen, doesn't it look like product rule on the top of quotient rule?
Yeah.
Product rule is f prime g plus g prime f, right? Quotient rule is f prime g minus. Now why would there be a minus? Because which function is on the frickin' bottom? G is on the bottom. So what's the power on it? -1. That's why it's minus. So when you have a g prime, it's got to have a minus sign because it's got a negative power. Are you guys semi with me at all? If you know the low, D, high, blah, whatever, great. But I think it's better to know why it acts the way it does. So it's the derivative of the top, which is 2x minus 3, times the bottom, minus derivative of the bottom, which is just 1, times the top, all over the bottom squared. And away you go, whatever the hell it means. You guys with me?
Yeah.
Okay. And now you got 2x squared minus 5x plus 3 minus x squared plus 3x minus 2 over stuff. Okay, that's just no joke. Okay. So then you get x squared minus 2x plus 1 over x minus 1 squared. And guess what this is? X minus 1 squared. 1, there, okay. Right? Yes, Dave?
Yeah.
Okay. So if you do quotient rule, you should get there. It's just going to take you longer. So definitely look for how to simplify something. Even if the top didn't factor, you could long divide. Or dare I even say synthetically divide. Is everybody cool with that expression, synthetic division? You guys know synthetic division?
Yeah.
We will cover it again, because it's a stupid important thing to know. It's freaking awesome, synthetic division. Okay, so we'll cover it, don't worry. Later this semester, we'll definitely cover it, maybe sooner than that. All right. Please, dear God, if any of this is not making sense, you got to stop me immediately. Don't let me steamroll you, right? And you guys in the front row, you can make sure this guy's, he takes union breaks sometimes, so. What about part D? Why is that the easiest problem on there?
Constant. 0.
Because it's a constant, right? So I get a lot of people tell me it's 2 pi. No, pi squared is just the number, so its derivative is 0. Gas. Kind of related to another problem here in a minute. All right. Now we got these guys. Oh shit. So some of you guys might like to write it as like, how can you rewrite this? Bring it up. 2x to the negative 2, right? So it's not a bad idea. The other one I could just leave because it's actually related to its, right, what's the integral of 3 over x?
3 ln x.
3 ln x, I love it. We'll see. And then, what's the integral of this? How does that work?
You add 1 to the
Yeah,
exponent.
so I'm gonna write it down, change the power, add 1, and then divide by the new power. Right? Is that cool?
Yeah.
The power goes up, and you divide by the new power. Kabam. Kick ass. How do you check any integral problem that you do? Take the derivative and see comes to the blah, blah. Exactly. All right. Now, just to kind of set the tone for the semester, and it's not just because I want to do this to you, it's because that's a huge part of what you learn in this, is trig. There's a lot of trig methods. There's integrating trig in different forms. You have to know your trig identities. I don't know what the shit integral of tangent squared is, but what is tangent squared x plus 1? Thank the gods, because what's the integral of secant squared? Freaking tangent. Tangent x.
Plus C.
Plus C. Good. You guys doing okay? And again, you guys, I keep saying this, but dear God, if you had trouble with this worksheet, the point is not to freak you out. You know, you should be somewhere where you're having some trouble with this because you don't do this every freaking day. So it's going to leak out your brain pretty quick. This is just to kind of get things going again, right? Here's the one I think I ended up talking to everybody about, right? Let's see, EDT. ET. E is just a constant, right? So what would the integral of E dm be? Integral of E dm. EM plus E, right? Okay. Incredible. By the way, real quick, side note. Real quick. It's going to seem really silly, but it's going to become very important soon. So what's the integral of dw? Just like that. Integral of dw. You can do it. W. What's the integral of L? L plus C. So watch this. What is the integral of dxy? Yes, xy plus c. Are you guys right? Integral d shit is equal to shit plus c. Or stuff, or whatever word you wanted me to say. Sorry. All right, I like it. Okay. By the way, real quick, if I offend you, just wait a minute. I'll probably do it again. No, but seriously, if I do offend you, let me know. But I do sometimes use language. Okay. We're all freaking adults. What about this one? This is our first example, I believe, of that method we alluded to earlier. USO. This is a classic USO. There is a function stuck inside of another function whose derivative is in there. That's the classic USO. It's not the only way USO works, but that's the classic USO. There's something stuck in another function whose derivative is in there also. Now, is 8y the derivative of 2y squared? No. Hell no. I don't give a shit. Constants, I can make them do whatever I want them to. We can bring them in, bring them out. We can do 1/2 and put a factor of 2. We can do anything we want to with constants, right? But what if this was integral of 8e to the 2y squared? That y wasn't there. Would I be able to do that?
No.
Is there a function whose derivative is in there? No. And to be honest, this is one we're going to learn how to do later. You can't, it's impossible to do in a closed form. What does that mean, Jeff? We'll talk about it later. Thank God that's there. That's something y squared, so I need something y outside. That means I can do it. So what am I going to let u equal?
2y squared.
2y squared, the stuff that's stuck. So what's du?
4y.
4y dy, right? So do I have 4y dy? I've got too much, don't I? Now, real quick note, I'm not gonna be able to wean you off of this habit, because some of my colleagues teach this. Does anyone solve for dy here?
Yeah.
It's bad, but again, it's fine if you're careful, but it makes you think you could do more than you can. I much prefer, and again, if you do that, keep doing it, you're fine. There's nothing really wrong with it. It just sometimes will lead you down the wrong path. I want 4y, I got 8y. I'm just gonna take a freaking factor of 2 out, and then I got exactly what it needs, right? So if I just take a factor of 2 out, now I got a 4y. Here's 4y dy. Well, that's du. And here's e to the stuff. Well, that's e to the u. So that's more of a construction approach. You construct what you need. And then what's the integral of e to the u?
E to the u.
And what was u?
It was 2y squared.
2y squared plus t. You guys, is that cool? Some of you guys, I like it. Some of you guys have this bemused look on your face, like, yeah, I was gonna know all this shit on day one, Jeff. Whatever. No, but again, that wasn't my point. I didn't think any of us would be able to do all of this worksheet, right? That'll be crazy if you could. Okay. Now these are the ones I think maybe not everybody got to. I don't know. I really want to get you guys to a point where you don't have to do this. What method do you think you're going to use here? And you don't have to. You really don't. Totally fine to do it. Nothing wrong with doing it, but it's just a waste of time. Do you notice how the inside is linear? You guys agree? And isn't the derivative of it outside?
Oh, yeah.
Right? So what would the integral of sine something be? Integral of sine something would be negative cosine that thing, right? And if you take this derivative, won't it be sine pi x times the derivative of pi, which is pi? It's there. I don't need to waste time with you subs. Let me do a couple more real quick before we finish this. And you're all like, do what you want to, man. You're the freaking teacher. What have I had to do? Integral e to the 3x. I do not have to use freaking u sub. E to the 3x. Why is that wrong if I think that's the answer? What would I get if I take the derivative? A factor of 3. So I just put it over freaking 3. That'll kill the 3 that wants to come down. So if the inside is linear, you really don't need u sub's help. You don't. Is it okay if you use u sub? Yes. Use it. But I want to start you to realize, oh, I don't have to use u sub all the time. If it's just linear, who gives a shit? I can make it work. It's just a constant that I got to make work. Maybe? Yes?
So for 3, then it'd be negative cosine pi x over pi?
No, because the pi's already there.
Yeah.
So it'd be like negative pi sine pi x over pi.
Wait,
Pi's would cancel. Right?
write it
So
out,
again,
sorry.
so it would be, if you wanted to do it the way we just did it, it'd be negative pi cosine pi x over pi. These
Move the
would
paper
cancel.
over?
I'm sorry.
Oh.
Yeah. But there's no reason to do that. Sine would go back to negative cosine. The derivative would have a pi pop out. It's there. So that's it. You're good. You don't have anything to adjust for. Now again, if you use u sub there, you're fine. We're just trying to get you to realize you don't have to. Right? Just to save a little bit of time. Okay. And of course, this is a definite integral. So then I just got to plot those guys in there, right? Then a cosine of pi over 2 plus cosine of pi over 6. And on these kind of problems, I sure as all hell want an exact answer, not some decimal approximation, right? So yeah, you got to know what the hell cosine of pi over 6 is. Cosine of pi over 2, come on. What's cosine of pi over 2?
0.
Shit, yes, right? Because cosine likes x, and at 90 degrees, there's no x piece, it's all y, right? So personally, I hate SOHCAHTOA. SOHCAHTOA, you know, you can make all kinds of camp math jokes and bullshit, but cosine likes x, sine likes y, gets you through everything, right? Yes?
So instead of doing a cosine pi over 6 minus the cosine, you just flip them over into the left?
Yeah, I put that in first,
Oh, okay.
And then it's minus a negative, so plus. Yeah, yeah. So that's 0. What's cosine of 5 over 6? Kick ass. You don't like it? We put a plus C here? No. Why not?
This is definitely.
It's definite. And of course, each piece would have a plus C and they would cancel. So that's why there's no plus C. Okay. And then finally, the least calculus thing on here. There's actually no calculus in this problem. Who did something with this? Anybody? Did y'all go, maybe he'll forget about that? What is this? Inverse cotangent, right? So tell me this, what kind of thing do you put inside of cotangent? Physically, what do you put inside of cotangent? It has to represent an, give me a problem, cotangent of what? I could ask you cotangent of, give me an example problem I could ask you. I could say, what's the cotangent of? Pi. Or I could say, what's the cotangent of 75 degrees, or whatever, right? So what do you put inside of cotangent? And what's pi? What's 75 degrees?
An angle.
Angle. You guys with me? I love it. You're all like, just get to your point now. Stay with me now. So if I put an angle inside of cotangent, what is the output of inverse cotangent? A freaking angle, right? Isn't that how inverse functions work? The input of one is the output of the other. Yes? That's how inverses work. So this inside says, this represents the angle where the cotangent is x minus 1. Can't you draw that triangle? Stay with me. This means the angle, this represents the angle where the cotangent is x minus 1. That's what that means. Can I draw that triangle? I can draw a triangle and label it given any inverse trig statement. What is cotangent the ratio of? Like sine is the ratio of the y side to hypotenuse, or the opposite over hypotenuse. Is that me? No, okay. Yeah, cotangent is x over y, right? The x side over the y side. You guys semi with me?
Yeah.
I really want this, okay. Is the inside a ratio? But I can just put it over 1, right? So I want a triangle whose cotangent is x minus 1 over 1. So that would just mean this is x minus 1, that's 1. And now the question is, what's the sign of that, right? If I'm given an inverse trig, I can draw a triangle. Because the inverse trig means it's an angle whose cotangent is x minus 1. So there. Wouldn't that be, if I put the angle right here, isn't that the cotangent of this angle would be x minus 1, yes? How do you figure out what the sign is? What am I missing? Hypotenuse. And what do you do to get hypotenuse? Old Greek dude. I love it. So then old Greek dude, it'd be x squared minus 2x plus 1 plus 1. So then you can answer it finally. Sine would be the y piece over the hypotenuse. And it should be square root. You can do it, Jeff. And then you can rationalize out here. That's one. Does that strike anybody's memory? You guys should have done some of those in pre-calc. And of course, some of you guys, maybe it's been a few years since you took pre-calc. Or maybe that period of your life is blacked out. I don't know. Y'all looked shell-shocked, I'm sorry. So real quick, if I had, let's do another one real quick. If I said, what is the tangent of the inverse cosine of 3 over x? What would that triangle look like? Well, the cosine to be 3 over x, so what's got to be 3? Sure, the adjacent. And where's x? Hypotenuse, right? Isn't cosine the x piece over the hypotenuse? Because at all with me?
Yeah.
Okay, I like it. So, just to really make sure you understand, it's cosine inverse of 3 over x equals an angle. Yes? We talked about that a minute ago. I put an angle in. So if I take cosine of both sides, I get 3 over x is cosine beta, which leads to this triangle. So I can just go straight from inverse trig function to a triangle. Now what do I need to figure out for the tangent? Yeah, I need this side, right? And of course, how do I get that side? Old Greek do it again. So it'll be square root of x squared minus 9. And then the tangent would be square root of x squared minus 9 over 3. Okay, maybe? That is going to become huge in one of the later sections in chapter 7. Believe it or not, we're going to be doing exactly that work I just did. This isn't me just going, "Hey, look at this weird shit about trig." No, this is actually going to happen to us relatively soon. So if it doesn't strike a memory, that's fine. Let's see if it makes sense now, right? Maybe. Okay, so I do want to do a little bit, unless there's any questions. And again, as these things come up, we will review them, right? So when we get to the trig heavy stuff, I'll review some of the identities, I'll review some of the inverse stuff. You guys with me? So I'm not going to just, there, you know all of it now. No. This is just to kind of dredge up some memories. Okay. All right. So what I want to do, in the little bit of time I've left, I've been scribbling some stuff down on the board. So I just want to show you guys. Look at this here, for example. That top one. What method would you use to integrate that? Let me write it over here. Yeah. Yeah, U sub, right? And again, it's a classic U sub. There's a piece stuck. What piece is stuck? X squared minus 1. What's the derivative of that?
2x.
Something x. Do I have an x? Yes. If that wasn't there, I'd be screwed. And to be honest, there's a section in chapter 7 where we actually develop a process to do this. At this moment, you don't have a clue how to do that shit. Right? If that's there, that's just undoing a chain rule. So U sub is what I call calculus answer to chain rule. Okay, maybe. Now, what about, so that U sub would work. U is x squared minus 1, check. Du is 2x. So what I would do is, I would say, I need a 2 here. Just like Indiana Jones, I've got to take something away to be able to put something. You guys ever seen Raiders of the Lost Ark? Yes? No? Took the thing, put the thing. He didn't balance it correctly, so of course the boulder comes down. There shouldn't be any boulders coming at you if you do that wrong, but just be careful, right? So, is everybody cool? So there's my du, and there's my u to the 1/2, and then that's an easy integral. Is that cool? I'm not going to do it because I'm trying to make a point. What about this freaky dude? Do you think u sub will work here? Looks like it shouldn't work, right? Because the inside power should be higher, but it will work. Let's try it. Believe it or not, it's going to work. So if I let u equal x squared minus 1, and this is the u sub stuff that sometimes teachers don't show you. We sometimes forget to show the full flexibility of u sub. So it's not your fault if you haven't seen this too much. What's du? Holy shit. And somebody tell me what's x squared? If u is x squared minus 1, x squared is u plus 1. It's just substitution. That's all it is. That's why you can do more with it than you realize. It's just substitution. So watch. Can't I break this up into what, Jeff? X times x squared. Right? And then I need a 2 still, just like I did here. Okay. Do you see du? Yes. So that's du. What's x squared? U plus 1. And what's square root of x squared minus 1?
U.
Square root of u, so it's u to the 1/2. Then you distribute, and easy as shit. Yes? Distribute, now it's just integrating stuff with powers. You're like, please give me more of that. But you don't get to see that very often. Has anybody ever seen that use of u sub before? Some of you guys, hopefully, right? But sometimes teachers just sort of forget to show the further application as a u sub. It's just substitution. So whatever legal way, you can make all the x stuff become u stuff. You're golden. So that's completely legal. Everything I just did is completely legal. I'm good to go. Maybe. Okay. And the same thing would happen with this. The exact same thing as what we just did. Yes? If I let u equal that, I can break that up into x and x squared, blah, 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 blah. Okay. Maybe. I love it. How did the first night go? He blah-blahed some shit. I don't understand what it was. Damn it. All right. Okay. So. Now. I want to do one new thing with you tonight. Okay. And then I'll let us all out. Okay. This is kind of good. I don't want to get you. How many erasers do you need? I don't want to get you too used to leaving early. I will let us out early sometimes. I'm not one of those people that have to keep us the whole time. Tonight just doesn't look like it's going to happen. So yeah, man. Okay. So this is really cool. Anybody agree with me that this is easy as hell? What's that interval?
Sine X.
Plus c. Yeah, so it's sine plus c. Of course, sine and cosine, you got to be careful about which way you're going. You with me? So it'll be positive sine plus c. Okay. What if I do this one thing? I just put one extra thing in there. That seems to blow it up, right? Uh-oh. Somebody's like, I can't do this shit. All right. Do you guys see how I just added one simple thing, x, and it completely blew it up? There's no 180 that can touch that. You guys see what I'm saying? Yeah. There's too much going on. So, I want to show you where this method comes from in the little bit of time I have left. Let's see if this is going to happen. So, recall. If I have, let's say, h is equal to f times g. What is h prime? I need another art. So what rule is that going to be? Let's see who's going to work. I have so many weird colors in here. What the shit? Well, as long as they work. I got lime. What am I doing with lime? Okay. All right. Somebody's going to work. It would be f prime g, right? Plus g prime f. I love it. And what is that? Product. Okay, I love it. Right? So, let's do this. Let's do something a little bit on the side of that. Let's say we have this, but let's let f of x equal u and g of x equal b. So it's really u of x and v of x. I'm just trying to write it shorter. Some of you guys know where I'm going with this, maybe the u's and the v's. Okay. Some of you guys don't. It's okay. So what does this become then? The derivative, let me see if you guys are cool with this. The derivative of h, let me check in with everybody. Is everybody cool with that? Instead of writing prime, I'm going to write d by dx. Is that cool? And what did I take the derivative of? I took the derivative of h, which is this. Yes? That's equal to f prime g plus g prime f. Just let me do that. All right. So let me replace stuff with u and v. Stay with me now. I've done nothing too weird up here yet, right? Y'all know prime is d by dx. And of course, I should have done this. D by dx f. And then d by dx. Okay, that'll become important in a minute. So I got d by dx, uv, right? Is that cool? uv. It already looks better, right? Equals d by dx f is d by dx of u, right, times v plus d by dx v times u. Okay. Again, nothing that amazing happening. You're like, sure, man, you can call it u and v, whatever the shit, didn't change anything. Okay, now watch. Okay. I think maybe you guys are sort of, all I did was call f u and g v. That's really all I did. Nothing amazing. But, do you all agree with me that dx is canceled? Do you see that? So I get duv equals du times v plus dv times u. Don't worry, if you guys know vectors, I'm not taking a dot product. Don't, it's just the times, okay? And then, stay with me now, and again, this is a derivation. I'm trying to show you where a rule comes from. The most important thing is to remember the rule, but I want you to see where the hell it came from. We didn't just go, let's say it's this. Sometimes no, it's not true. So watch, if I integrate, now you understand why I asked you that weird question earlier. What is the integral of d uv? uv. Ultraviolet. And then here I get the integral of v du plus the integral of u dv. You guys with me? So now you're all like, how the hell does that relate to this shit, Jeff? I don't know. Let me pull that last thing up. Now watch. I'm going to solve for this. So the integral of u dv equals uv minus the integral of v du. And you're all like, u and v and shit. All right. How the hell does this work? Now watch this. Any integral that I have that is in this form, you with me? Isn't this, if I let this be u, and I let this be dv, what is that the derivative of? What is cosine the derivative of? Sine. So it is the derivative of something. So there's a function, u, and there's a derivative of a function, dv. Right? In fact, I should include the whole thing. So this tells me how to rewrite it. So watch, let's see how this works. If I let u equal x, and I'll let dv equal cosine x dx. Let me stop for a minute. What's du? 1 dx, there it is. And what is v? So what am I doing now here? I'm going to do what to this? I'm going to integrate it. If I know what dv is, how do I get v? Integrate. So what's the integral of cosine? Sine. Do you have all the parts? Look what this needs. This needs u, this needs v, this needs v, this needs du. Okay, we got everything. So the original integral equals ultraviolet uv minus the integral of v du. What's that? Yeah, the integral sign is negative cosine. So that is what it is. Let's check it. How do I check it again?
Find the derivative.
Find the derivative? Okay. Oh my god. So if I take x sine x plus cosine x, the c is going to die, so who cares about it? Put a little c in. Derivative of x sine x will be derivative of x times sine plus x times the derivative of sine plus derivative of cosine. This cancels, and I get x cosine x. Yes?
Yeah.
So it checks. Now again, we went kind of quickly through that. Right. I just want to lay some groundwork. You're not supposed to come away tonight and totally understand this. In fact, the name of this is integration by parts. Integration by parts. And you can see why. There's a part you call u, and there's the rest of it you call dv. So it is very subtly different from u sub. So next time we'll go into that. I'll have a handout all about by parts. I'll probably bring the handout that I used to use for U sub, just in case anybody needs a refresher on U sub. Otherwise, I think that's plenty for today. So, yeah, we're leaving way early, like a couple minutes. So come up if you have any questions or anything. Otherwise, I'll see you later.
Oh, yeah, I didn't, it's like a triangle.